Okay, good morning. Can you hear me? Can you see the slide?
Yes, sir.
Okay. Okay. Okay, can you see the cursor moving? Cursor moving.
Yes, yes. Yes.
Okay. Wait, I check first. Okay. Good, good morning. Okay, so thing is already 8:02. Okay, so all these classes we will start on time because we only have a very limited time. Then you have a next class. Okay, so we have stopped with variation of pressure and depth. Okay, in our previous class. Then I think we have a few more slides to cover. Ada beberapa slide kita kena cover lagi. Okay, for this part. Okay, so for part 2, I akan bagi lecture lecture synchronous lecture, the add puzzle video. Okay, for part 2. Dan kita akan discuss lah macam hari tu. Okay, so I think next week kita ada sedikit perubahan dalam jadual because I think Wednesday is a Merdeka. Okay, so Independence Day. So kita cuti umum kan. So we need to replace that 2 hours class other time. So nanti you all suggest lah berapa kita boleh ganti. Okay, so it's okay. The announcement I will give at the end of the lecture. Okay, so for now, we just go on with from where we stop. Okay, so as we have seen the variation of pressure with depth. Okay, untuk cecair, so ini adalah permukaan air. Okay, so the surface of the water. Okay, as it goes deeper, the pressure will increase. So pressure akan, so dekat atas ni pressure kurang, dekat bawah ni dekat dasar laut. Okay, at the bottom of the sea, the pressure will be very high. Okay, so that's for the liquid. Okay, so as you can see in this picture, it can explain why the water pressure at the different point will be different. Okay, so kenapa dia macam tu? So why is like that? Because of the gravitational field. So because of gravity. So ada water molecule. So water molecule dia ada weight. Okay, so naturally because of the gravity, more molecules will be at the bottom of the sea, and intermolecular force is actually pushing, creating the force. So that's why dekat atas ni molekul kurang, dekat bawah molekul tinggi, banyak. So the pressure will be more at the bottom of the sea. Okay, so you can see all this here. Okay, so Fz. Okay, Z is your height. Okay, the force equals to MAZ, acceleration. Okay, equals to 0 because you can satisfy this. So nanti kita tengoklah apa ni. Okay, what is this? Okay, pressure 1, pressure dekat atas. Pressure 2 adalah dekat bawah. Okay, and rho G adalah density of the water or whatever liquid. Okay, kalau like air laut lah. Okay, so the density times with gravity. Okay, so gravity is playing a big role here. Okay, so continuation of the slide. Okay, so W. So W is the weight. Okay, weight of the fluid element. Okay, so whatever liquid it is having weight and density. And Z is the depth change or the height change. Okay, so perubahan kedalaman. Okay, Z2 lagi dalam minus yang permukaan ataupun yang ke atas lah. Okay, so I can see here in this picture, so Z adalah ketinggian. Okay, so is the height and this is your distance. Okay, so let's say you have something emerge in the water. Okey, ini adalah permukaan air, ini adalah kedalaman. Okey, so ada dua pressure. So pressure dekat atas dengan pressure dekat bawah, P1 and P2. Okay, so if you see P1, if the molecule at the same level, so the pressure garisan ni dia sama sama panjang. Okay, so kalau you tengok ya garis dekat atas ni pendek daripada yang kat bawah. Sebab dekat bawah pressure lagi tinggi. So at the bottom the pressure is more. Tapi at the same level, same point, the pressure line sama panjang. Ikut ketinggian. Okey, apa Z, perubahan Z. So atas arrow kecil, ke bawah lagi panjang. Okay, so as the depth increases, so the arrow also increases, meaning the pressure is increasing. Okay, so perubahan P, okay, the changes in the pressure. So P2 yang lagi besar, tolak lagi kecil. So P2 minus P1. So ini equation dia rho G Z ataupun rho G H lah. Tapi dekat sini Z adalah H. Okay, so you boleh tengok dekat sini. Okay, so the pressure in a tank containing a gas. Tadi kita tengok liquid. Okay, earlier we seen liquid. So now with the gas. So what changes that is making? Okay, the pressure in a tank containing a gas. So ni adalah satu tank. So dalam ni ada gas. Okay, so you have air here. Okay, so this is a 5 meter air room. So since it's a square, so 5 meter kali 5 meter kali 5 meter. So that's the volume of the room. Okay, so the pressure a tank containing a gas can be considered to be uniform since the weight is too small to make a significant. Okay, so air. Okay, bukan air. Okay, air. Okay, so air, the pressure is uniform because the weight of the gas will be very small. So it's not like a liquid. Liquid, kalau one volume of liquid, so it will be heavy. Tapi the similar amount of gas will be small. The weight will be small. Okay, so it's not making any significant. Maksudnya dia tak cause anything. Okay, so that's what we say here, not making a significant. The pressure in a room filled with air can be assumed to be constant. So dekat bottom, tengok dekat atas. So on top, one atmospheric pressure. Dekat bawah 1.006. So it's still negligible. You bunda pun still dapat satu. So it's not really making any significant. So that's why they say it assumed to be constant. Okay, so this is for gas. In a room filled with the gas, the variation of pressure with height is negligible. So negligible maksudnya boleh diabaikan. Okay, so for liquid kita tengok tadi. So take point 1. Point 1 adalah dekat atas permukaan. So permukaan P1. So we have seen in the previous lecture. Dekat permukaan ni dia sama dengan atmospheric pressure dekat atas. Sebab dekat atas ni udara kan. So dekat atas ni adalah atmospheric pressure. So P1, point 1 dekat sini adalah atmospheric pressure. So atmospheric pressure normally will be 101 kilopascal. So dekat atas. Tapi dekat bawah dia ada perubahan dekat ketinggian. Okay, so there's a difference in height. So P2 formula dia adalah atmospheric pressure. So pressure dekat sini tambah dengan rho GH. So ini formula yang kita akan selalu gunakan untuk static fluid. Okay, so P equals to atmospheric pressure plus rho, density of the water, times with gravity, times with height, H ni. Okay, so this is the first formula. And you have a gauge pressure. Okay, so you are using a device. So I dah bagi tahu hari tu. So kita selalunya kalau device kita start dari kosong. So we will start from zero. So when we start from zero, selalunya device kita pun macam I bagi tahu contoh hari tu weighing machine. So even though our weight is uh, will be more, tapi kita selalunya start dari kosong. So it's like something like that. So walaupun dekat permukaan ni atmospheric pressure adalah 101 kilopascal, tapi untuk gauge pressure, so apa alat pengukur, so kita jadikan atmospheric pressure dekat atas ni kosong. So apply dekat formula ni, so P equals to PATM plus rho GH, or gauge pressure P gauge equals to 0 plus rho GH. So ATM jadi kosong. So tinggal rho GH. So only left rho GH. So this formula also you need to understand. So pressure in a liquid at rest increase linearly with distance from the free surface. Free surface dekat atas, okay, so is on top. So increases linearly with the distance, meaning as it goes down, the pressure will be increasing. Okay, so we have seen for two types of fluid. The first one is gas. At different height, the pressure can be constant. Okay, dia sama because of the weight too small. But for liquid, as the depth or height is increasing, the pressure will be more. Okay, so this that we want to understand. Okay, so we will see. I think you will understand better when you see this. Okay, so pressure in a fluid at rest is independent of the shape of the container. So katakan yang ni adalah satu container dekat bawah ni. So if you can see, so the shape is irregular. So shape dia boleh macam-macam. Okay, shape dia boleh macam-macam. Macam ni lah. Dia bentuk pelik kan. So you are filling this with water and one part dia ada mercury. Mercury. So meaning there's a difference in density. Okay, so kita tengok, kita buat analisis sikit. Okay, pressure is the same at all point on horizontal plane of the given fluid. So tengok, yang ni adalah horizontal plane. The horizontal plane. So dekat horizontal plane, so it can be a lot of horizontal plane. Okay, molecule at this sama ketinggian. So molecule ada dekat sini, ada dekat sini, ada dekat sini. So setiap tempat pun ada molecule. So the molecule at the same level will be experiencing the same pressure. So itu yang dia bagi tahu lah. So pressure is the same at all points on a horizontal plane. Okay, horizontal plane. Okay, so pressure at point A, B, C, D, E, F, and G are the same. Tengok. A, B, C, D, E, F, G. Semua ada ketinggian yang sama. Walaupun shape dia lain, tengok shape dia ada dekat macam ni, kemudian ada point B. Kemudian ada sedikit difference. But the idea is all the points must be at the same level. Okay, yang itu adalah satu condition. Okay, so it's one of the condition. So all the points must be at the same depth, same height. Okay, height ni adalah H. Okay, then the same static fluid, same fluid density. Maksudnya, tak kisah permukaan dia macam mana, so tak kisah container dia, size dia macam ni, macam mana, tapi dia kena sama air and sama liquid. So meaning if water, so all these are connected in water. So tengok, same. So all are connected in the same liquid, water. So it means the condition that all the pressure of these points are the same. Boleh tengok dekat bawah ni. Okay, so PA, pressure of A sama dengan pressure of B, pressure of C, sama dengan pressure of D, sama dengan pressure of E, sama dengan pressure of F, dengan pressure of G. So all the same. So berapa? So atmospheric pressure PATM campur dengan rho adalah density of the water, uh, times gravity times dengan air. So katakan yang ni 5 meter kali dengan 5 meter lah. So you can find the pressure. Okay. So kita tengok satu lagi example. So pressure at point H and I. So H dengan I dia dekat bawah ni. Okay, H dengan I sama ketinggian tak? H dengan I ni. Is H and I having the same depth? Sama ketinggian tak? Anyone there? So can you give answer? H dengan I ni sama ketinggian tak? Siapa on cam? Siapa on mic? Sama ketinggian ke tak?
Sama saya. I think sama. Nampak sama kan?
Sama kan? So H dengan I sama ketinggian. Tapi dia fluid dia berlainan. Dekat sini water, I dalam water, H dalam mercury. Kan? So since mercury is having more density than water, automatically dia pergi ke bawah sebab dia lagi berat. So it's more heavier than water, so automatically it goes there. So tapi condition untuk pressure to be same, dia kena ada dua condition. Satu, sama ketinggian. H dengan I sama ketinggian. Okay, tapi dia ada dalam liquid. So dia kena condition kedua, same static liquid. So kalau tak ada mercury dekat sini, but it's water, then you can consider that pressure of H and pressure of I will be the same. Tapi since first condition is met, first condition sama ketinggian, tapi tak sama liquid. So pH not equals to P1, PI, sorry. So pressure dia tak sama. Okay, so that's the thing that you need to understand. Okay, so you can try yourself. Okay, cuba buat calculation ni. Okay, calculate the change in water pressure. So disuruh cari water. So they already say it's water. So water pressure from the surface. So from the surface maksudnya at the surface the pressure is atmospheric pressure. So P1 equals to PATM. Okay, to a depth of 5 meter. So the depth is given in meter, 5 meter. So they are asked to find the changes in pressure. Changes in pressure. So ini adalah satu keyword. Change in pressure. Maksudnya, you kena cari P gauge. So P gauge tadi kita tengok kan. P gauge. So you use this formula. So atmospheric pressure tu kita assume as kosong. Okay, so if the surface of water is exposed to the atmosphere, the pressure change is 0 Pascal gauge. Meaning PATM, so atmospheric pressure. So kita start dari kosong. So kita tulis macam ni. So the pressure change there is 0 Pascal. Tulis dalam kurungan gauge. Descending in the water, decreasing elevation produce an increase in pressure. Okay, so inside the water. So therefore, at 5 meter, the pressure is yang ni lah, gunakan formula ni. So P gauge equals to rho GH. So rho of water is 1000 kilogram per meter cube. So gravity 9.81 and H is 5 meter. So you solve this. you can get this answer. Pressure is 49.05 kilopascal gauge. So kena tulis gauge ni. Uh, if not, you need to add with atmospheric pressure. Okay, so ada soalan setakat ni. Okay, no question. Okay, so gas pressure variation with elevation. So earlier we have seen about liquid. Now we see a bit on the gas. So gas, as I say, gas normally will be at the surface level. I mean at the bottom. Kemudian dia ada ketinggian. So it's having a elevation. Elevation maksudnya ketinggian. So it's elevated. Elevated maksudnya dia ada ketinggian lah. So air density at sea level, so 15 degrees Celsius, dia sama dengan 1.225 kilogram per meter cube. Okay, so it's a quite light lah. So if compare dengan yang water tadi, water 1000 kilogram per meter cube. Tapi gas 1.225. So meaning 1000 times lagi ringan daripada air. Okay, so the pressure difference at 5 meter height. So we're still using the 5 meter. So meaning at the sea level kosong, ikut ketinggian dia 5 meter lah. Okay, so we are calculating. So rho GH. So rho is 1.225 times with 9.81 lah. Selalu kita ambil 9.81 times with 5 meters. Ini adalah unit conversion. So kalau tak tahu nak buat yang ni, so tengok chapter 1. Okay, so you check here, you settle all this, so you dapat rho GH adalah 0.06. So it's very small. Even so lagi tinggi pun is still negligible. Okay, so atmospheric pressure is 101.325 kilopascal. Okay, so for gas, the variation of pressure with air is negligible because of the low density. Disebabkan density, so the changes in pressure is small. Also the weight is small. Berat angin tu adalah kurang. However, so generally kita neglect. So kita abaikan. But however, if accuracy is desired, it becomes significant. If that small change have huge impact in the application. So dia still bergantung kepada application. So it still depends on what you are measuring. So kalau you nak measure 0.06, yang ni ada perubahan. So perubahan ni is something that you concern. So meaning normally like the rocket. Rocket, even the small values, you need to know. So kalau application you macam tu, then the small thing is significant. Kalau tak, kita boleh abaikan. So kalau yang ni is taken into consideration, so you need to measure that. Kita tak boleh abaikan. Okay, so that's what they are saying here. Okay, so gravitational effect G equals to 9.807. Okay, at sea level ini adalah gravity. At elevation 14,000. 14,000 ketinggian dari sea level. So G equals to 9.764. Okay, so which is 0.4% change. Therefore, G variation is so small and G can be considered constant. Kalau you bunda pun, you dapat 9.8. So they almost the same lah. So almost the same. So we always consider that the gas or the gravity is always constant. Okay, so that's from this slide. Okay, so try to do this example. Okay, so you have a container with oil. Okay, so here you have atmospheric pressure and you have a trapped air inside. Okay, so you can see there are few points A, B, C, D, E, F. So try to answer this question based on whatever you have learned. Okay, so tadi kita tengok kalau pressure dia, point dia sama, same level and it's in the same liquid. Same liquid, then you can consider the two pressures are the same. Okay, so kita tengok untuk yang ni. So figure below shows a tank of oil with one side open to the atmosphere and the other side sealed with air above the oil. So maksudnya you ada satu tank. Okay, one side open. So one side open to atmosphere. So meaning that here you are taking the atmospheric pressure and the other side sealed with air. Okay, dia container dia macam ni lah. So you have air trapped inside. Okay, the oil has a specific gravity of 0.9. Okay, specific gravity adalah gamma. Okay, symbol gamma. Okay, so the oil has okay, calculate the gauge pressure at point. Dia dah bagi tahu. So already mentioned gauge pressure, meaning the atmospheric tak kisahlah whether the value is given in the exam. Sebab kita nak cari gauge pressure. Gauge pressure start from zero. So atmospheric pressure we neglect, then kita start dari kosong. Okay, so they asked to find from A, B, C, D, E, and F. So A, B, C, D, E, F. And the pressure in the right side of the tank. Right side of the tank maksudnya the pressure of air. Okay, how to find. Yeah. So kalau you tengok only certain values are given. Value of the initial pressure pun dia tak bagi. So hanya bagi value ketinggian. So macam mana nak calculate? Okay, so you can refer to the picture here. Okay, so first we find for A. Okay, point A, at this point, the oil is exposed to the atmospheric pressure and therefore, so it's a atmospheric pressure lah dekat permukaan ni. Okay, so because it's taking the pressure from the atmosphere. Tapi since we are using a gauge pressure, we are measuring the gauge pressure, kita at the permukaan ni kita ambil as kosong. So kita ambil as kosong. Okay, so PA, so pressure of A equals to 0. Okay, so A dah dapat. Okay, next B. The change in elevation between point A and point B is 3 meter. Ini adalah 3 meter A to B. Okay, with B lower than A. So B lower than A. The specific weight of the oil. So specific weight, the gamma of oil is Sg. Specific gravity of oil times with gravity. Okay, so gamma ni specific weight equals to rho g. Rho g. So you can see in chapter 2. So rho g. So rho is 0.9 and the gravity is 9.81. Ini something yang kita tahu. Okay, so 0.9 is given. So the gamma is, the specific weight is 8.83. Okay, so this is how you can calculate. Then you substitute. So pressure from A to B, bukan A minus B, A to B. So A to B is so specific weight times weight height. So 8.83. So you measured here. So times with 3 meters. So make sure the units are correct. So 8.83 times with 3. So you get here 26. So pressure at B is 26.5. So you dapatlah 26.5. We measured for using the formula. Okay. Okay, so now the pressure at B is, okay, sorry. Ini adalah pressure difference. Pressure difference, then you calculate the pressure, the gauge pressure. Okay, the pressure at B is PB equals to PA. So at the pressure from here to here. This is the pressure difference. Okay, so here PA is zero. Zero gauge pressure. Okay, zero plus with 26.5. So that's the changes. So 26.5 kilopascal. Okay, so you already found for B. Okay, now we are going for point C. Okay, pressure at C, PC. Okay, the change in elevation from point A to point C is 6 meter. So 3 meters plus 3 meters, 6 meter. With C lower than A. So C lower than A. So for this, you can measure from B to C or A to C. Sebab value of A pun you ada, value of B pun you ada. But this example is taking from A to C. Maybe because it's easier. Because PA is 0. Okay, so A to C. So changes of pressure in A to C is specific weight times I. Okay, specific weight we already know 8.83 times weight 6 meter. Okay, so you're taking the full line, full distance. So you're getting 53 kilonewton. So kilonewton per meter square. Conversion adalah 53 kilopascal. Okay, now we are finding C. PA plus weight changes. Rho GH kan. So 0 Pascal plus 53. So measured here. So you are getting PC is 53 kilopascal gauge. So gauge pressure. So you already found for A, B and C. Now D. So point D, because D is at the same level as point B. So B dengan D adalah same level. Okay, so the pressure is the same. So PD sama dengan PB. So that earlier we measured PB is 26.5 kilopascal gauge. Okay, so you already get for D. So now we are finding for E. So because point E is at the same level at point A. So kita tengok A dengan E. So even though you ada something alang ke bawah, but the oil is connected. So oil is connected. So this is what we could get from Pascal's law. Okay, so it's connected. So the pressure of A sama dengan pressure of E. So PE equals to PA. So earlier PA is 0 Pascal. Okay, so we already got A, B, C, D, E. So now we are moving to the last point. So point F, okay, point F is above the initial level. Okay, and dia adalah 1.5 meter. So the change in elevation between point A and point F is 1.5 meters with F higher than A. F higher than A. Then the pressure at F is changes in pressure AF equals to minus. Yang ni you kena minus lah. Sebab is different. Kalau it's increasing in depth, then you tambah. If it's more than the initial level, you tolak. So minus specific weight times height. So minus 0.83 kilonewton per meter cube terkali dengan 1.5. So 1.5 is the changes. So you are getting negative 13.2. 13.2, so you dapat negative 13.2 kilopascal. So the changes of pressure is negative 13.2. So you are finding PF equals to PA. So pressure at A plus with changes, yeah, between A and F. Okay, so 0 dekat sini kosong plus negatif 13. So plus and minus jadi minus. So 0 minus 13.2. So you dapat the pressure of F is negative 13.2 kilopascal because it's more higher than PA. Okay, so we already found the pressure for all the points. Tapi soalan ada satu lagi benda yang kita kena cari. So they ask to find the air pressure at the right side. So dia nak suruh cari the pressure of air. Okay, macam mana nak cari? So the air pressure in the right side of the tank. So here, the pressure of the air here, yeah, is exposed to the surface of the oil. So maksudnya uh, air pressure is sama dengan pressure of F. Itu yang dia nak bagi tahu. So the air pressure is also pressure of air minus 13.2. Okay, sebab PF adalah negatif 13.2. So negative 13.2. PF we already calculate. So the air pressure here sama konsep dengan yang ni lah. So since the surface A sama pressure dengan atmospheric pressure, so the similar concept is applied here. So the air pressure is equals to permukaan ni. Permukaan ni adalah pressure of F. So the air pressure is negative 13.2 kilopascal. So sama dengan pressure of F. Or kenapa negative? Because 13.2 below atmospheric pressure. So atmospheric pressure here is pressure at here, APA. So yang ni dia below atmospheric pressure because of the elevation. Okay, so ada apa-apa soalan setakat ni? Any questions so far? Okay, so no question. Sorry. Okay, so we have seen here. So we are going to the last point for today. So which is Pascal's law. So Pascal's law is applying whatever we have studied earlier, and Pascal's law is very useful in our daily life. Dia memang kita akan gunakan lah setiap hari. Okay, so Pascal's law is a favorite question in exam. Okay, selalu ada exam. So it's actually very simple to calculate, but it's something that always will come. Okay, so what Pascal's law is saying, a pressure applied to a confined fluid. Confined fluid meaning fluid yang ditutup. Okay, like here, you put a fluid here and you have a piston to tutup. Piston ni ditutup. So meaning the liquid is in a same container. Kita boleh cakap as a container lah. Okay, so confined fluid increases with pressure throughout the same point. Itu yang dia beritahu lah. So you apply pressure dekat sini is equals like you are applying pressure at here, even though the size is differ. The size differs. Okay, so in the picture, piston are the same height. Okay, piston 1, ini adalah piston 1, ini adalah piston 2. So it's at the same height. The same height. So we know that since it's connected and it's same liquid, pressure at 1 and pressure at 2 are the same. So P1 equals to P2. Okay, so pressure we know is a force over area. Okay, force over area. So F1, so you are applying a pressure F1 sama dengan area of 1 sama dengan pressure at 2 divide by area of 2. So you rearrange this formula, you dapat macam ni. F2 over F1 equals to A2 over A1. So that's the thing that you can get by rearranging this. So lifting a large weight by a small force by a application of Pascal's law. So maybe you ada soalan ni. Kenapa dekat bengkel kereta So you just use a normal jack, you tekan, kereta boleh naik. Because you are using the same principle. So you are applying a small force to move a larger force. Uh, so itu dekat sini you tekan, maybe a foot pedal or you have like a tolok. So you press, then you can see the car is going up because of Pascal's law. Okay, so you can consider here, consider a pierced vessel. So maksudnya you ada satu vessel, okay, and you have a piston here, and you tebul lubang. Pierce maksudnya ada banyak lubang. Okay, so you ada lubang 1, 2, 3, 4, 5, 6, 7. Okay, full of water. So inside you have a water, and you have a piston on top. Okay, so you are pressing this piston. So you are applying a force. So piston ni dia akan bergerak ke bawah. So what will happen to the water here? So the water will try to go out. Okay, and the water comes out of the vessel with a bigger intensity. So the rise in pressure is the same anywhere in the water. So ini air yang keluar dekat point ni, point ni, point ni, point ni, point ni. So will be the almost the same. Yeah, almost the same. Okay, so that's what Pascal's law is saying. Okay, some of the applications. So hydraulic brake. So brake dalam kereta pun gunakan Pascal's law. So you are applying a foot pedal. So you apply sikit je. Sikit je, tapi kereta berhenti. Because it's connected to the brake oil, and the brake oil is connected to the wheel. So you apply a bit of effort or a bit of force. Piston ni bergerak, so the fluid will be connected to here, and the fluid is moving the brake pad to brake. So that is how a hydraulic brake system works. Then this is something that we always see, jack system. So dalam ni dia ada all the liquid lah, so the fluid. So you buka dekat atas ni, so you isikan dengan minyak. So then you press, so this thing will push the car going up. Okay, so then you have a hydraulic grease gun to apply grease. So all these are some of the applications that you can see in the daily life that having an impact, helping you, dia tolong you, and at the same time is applying the Pascal's law. Okay, so you can do this example. Okay, so a force F of 800 Newton is applied to a smaller cylinder. So you can see here, so you have a similar kind of container. So dekat sini ada satu piston, dekat sini ada satu piston. So you are having a weight here. Okay, apply here. So kalau you tekan yang ni akan naik atas. So the direction will be different. You tekan dekat sini, yang ni dia naik atas. Okay, but the force will be almost the same. Almost the same according to the Pascal's law. Okay, so we try to apply Pascal's law to calculate this. So force applier is 800. So this is the smaller cylinder and bigger cylinder. So this is the application is hydraulic jack. Okay, the area A kecil equals to 20 cm square. 20 cm square. While the area of this piston is 200. So meaning this piston is 10 times larger than this piston. So generally, for our thinking, if it's larger, you need to apply more force. Okay, but it can be created using Pascal's law. Okay, so what mass can be lifted by the larger piston? So the suruh cari mass. Mass is not weight. So kilogram kali dengan gravity. Then you can get the weight. Okay, so some information are given. The force F1 area 1, A1, and also area 2, A2. So they asked to find F2. F2 berapa in terms of mass. Okay, so we see the calculation. So three informations are given. So this A is given in centimeter square. So you convert to SI. SI for distance is meter. So 20 divided by 1000. So you already convert to meter square. And this A 200 to 1000. Okay, so we know P1. So P1 equals to P2. P1 equals to P2. So P pressure is force over area. So F over A kecil. Okay, so F over A kecil sama dengan weight. Weight is a force over A besar. So you're getting this. F over A equals to W, weight over area. Okay, so you rearrange this since you already have three input. So the unknown is W. So W equals to yang ni naik ke atas. F times A over A small. Okay, so you ganti all this. So 800 divided by 2. So rearrange kan. So you rearrange dapat 2 over 0.2. 2 over 0.2. So the weight is 8,000. 8,000 Newton. 8,000 Newton. But the question is asking you to calculate mass. Maksudnya, you kena bagi weight 8,000 ni bagi dengan gravity. So 8,000 divided by 9.81. So you're getting the mass lifted. Here you're only applying a small force, but the weight lifted here is 815.49 kilogram. Okay, so that is how you use Pascal's law to calculate. Okay, calculate the unknown values. Okay, so you may try yourself. Okay, siapa boleh bagi answer? Okay, cuba buat. Okay, similar kind of question. So they are applying a force 1. Here, force 1 is not given, but weight F2. F2 is given to 500 kilogram. So it's not weight lah. So this is actually mass. Okay, so mass. So you need, since it's force, so weight, mass is not a force. So you need to times this with 9.81. Okay, baru you apply dekat Pascal's law. Okay, so you're saying weight is, so this is some mistake lah. So it's actually, if you want to say weight, you need to say 2500 Newton. Weight in Newton. Tapi in this case, you just assume this kg ni tukar jadi Newton. So that means, so this is 25 Newton, this is 2500 Newton. Okay, so diameter is given 10 cm and D2. So diameter of piston in meters not given. Okay, weight to be placed. Okay, so cuba carilah yang ni. Because three informations are given. Here 25, force F1 is 25, F2 is 2500, this is 10. So normally pistons will be bulat. Okay, piston, the permukaan dia adalah bulat. So the area that need to be calculated here is circle or round. Okay, so pi r square. Okay, so ini adalah diameter. So diameter is 10, so radius is 5 bagi 2. So pi r square. Okay, so cuba calculate. Siapa dapat? The value of D2. Dapat tak? Value of D2. Anyone? It's okay. You try to find. I didn't bring my calculator. So you try to find. Try to do it yourself and try to get the answer. Okay. So we have reached end of chapter 3, part 1. It is something that we haven't covered in the last lecture. Tak sempat habis. Okay, so any question? So we have like another 8 minutes. So I think you also need to go to the next class. So ada soalan? Any question?
No, sir.
Okay, so if no questions, I think we will stop here. Okay, so announcement. So announcement for next week. Uh, I will tell you because in between ada Merdeka leave. So Merdeka leave, so it's fall on our class day. So class day, so I might need to replace the 2 hours class. Okay, so lab pun I akan bagi tahu lah. Most probably we will try not to leave the lab lah. Okay, so I think that's all from me. So later I will give that puzzle assignment. So try to do. We will discuss in the next class. Okay. So thank you.
Thank you, sir.
Okay. Thank you.
Thank you, sir. Thank you, sir.
Okay.